We're going to solve a system of equations by using the elimination, or sometimes it's called the addition method. And in the elimination or the addition method, our goal is to get rid of either our x's or our y's when we add the two equations together. So you can see right now, if we added them together, we would end up with 5x plus 2x, which is 7x. If we added our y's, we'd have a positive 4y and a negative 8y, and that would give me a negative 4y. So I would still have an x variable and I'd still have a y variable. So my goal is to get rid of one of those variables. Some of the things that we want to look at when we're doing that is there a change in sign between my two equations and the variables that I'm trying to get rid of? So if you notice, on the x's, they're both positive. But on the y's, one is positive and one is negative. So that's something good to look at. The other thing you want to look at is what number are 2 and 5 both factors of? In other words, what number will 2 go into and 5 is a factor of it? And that would be 10. So to make each of these equal to 10, I would have to multiply this one by 2 and this one by 5. And then I have to have a change in sign, so one of them would have to be negative. So I have to multiply both equations, and I have to make sure that I change the sign also. Looking at the y's, I have a 4 and an 8. Well, my least common multiple, or the number that both 4 and 8 are factors of, is 8. And this second equation already has an 8, so that's good. So if I want to make this first equation have an 8, I'm going to need to multiply this by 2. So if I multiply my first equation by 2, and remember, you're going to multiply everything inside of your equation by 2, it ends up being 10x plus 8y equals 4. And then the second equation, we're just going to keep it the same. So now look at what ended up happening. I multiplied the first equation by 2. I ended up getting a positive 8y. I had a negative 8y, so there's my change in sign. So that now when I add the two equations together, my 8y's are going to cancel out. I'm going to have 10x plus 2x, which is 12x. And I'm going to have 4 plus 4, which is 8. And now I can solve my equation for x, dividing both sides by 12. And then reducing, I end up getting 2/3. Okay, so then I'm going to use this value and put it back into one of my original equations to find my y value. So I'm going to put it into the second equation, I guess. So I'm going to do 2 times 2/3, plugging in 2/3 where I have an x in my second equation, minus 8y equals 4. Multiplying this, I end up with 4/3 minus 8y equals 4. Now you can either solve this equation using fractions, or what a lot of times I suggest that we do is get rid of those fractions, remove them. So to remove them, I need to find the common denominator. My common denominator is 3, so I'm going to multiply every term by 3. When I do that, I end up with 4 minus 24y equals 12. Then I'm going to subtract 4 from both sides. Negative 24y equals 8. Divide both sides by negative 24. 8 divided by negative 24, which equals negative 1/3. So the point of intersection for these particular lines is the point 2/3, negative 1/3. And then we should always go ahead and check and take each of these points and put them in for x and y into my first and second equations. So is 5 times 2/3 plus 4 times negative 1/3, is that equal to 2? Well, 5 times 2/3 is 10/3 minus minus 4/3, and 10 minus 4 is 6, so then I end up with 6/3 equals 2, and that checks. I should also take my answers and put them into my second equation. So 2 times 2/3 minus 8 times negative 1/3 equals 4. 4/3, and then a negative times a negative is a positive thirds. Since I have a common denominator, I can add my numerators. and that becomes 12/3, which we know is equal to 4. So that checks also. So my answer then is the point 2/3, -1/3. So in the next problem, I'm going to still be doing elimination, but first thing I notice is that I have fractions, and we want to get rid of those fractions, so we're going to need to multiply by the LCD. Now the LCD for the first equation is a number that both 3 and 5 are factors of, and that number is going to be 15. And for the second equation, the LCD for 2 and 3 is 6. So the first equation I'm going to be multiplying every term by 15. The second equation I'm going to multiply everything by 6. So I'm going to take 15 times 2/3 x plus 15 times 3/5 y equals 15 times -17. And the second equation is going to be 6 times 1/2 x minus 6 times 1/3 y equals 6 times -1. And the reason that we multiply by our LCD is so that we can cancel out our denominators and get rid of them. So how many times does 3 go into 3? Once. How many times does 3 go into 15? 5 times. 5 goes into 5 once. 5 goes into 15 3 times. And then on the right we don't have any fractions, so we don't need to worry about that. The second equation, 2 goes into 2 once, into 6 3 times. And then 3 goes into 6 2 times, and the right side we don't need to worry about. So now my equations have become 5 times 2, so 10x plus 9y. So 10x plus 9y, and then 15 times -17 gives me a -255. The second equation, I end up with 3x minus 2y equals -6. So here I am again. I need to use elimination to get rid of either my x or my y's. The x's will also have to have a change in sign. So I'm going to stay away from the x's. I'm going to look at the y's. They already have a change in sign. And then I need a number that both 2 and 9 are factors of, that they can divide evenly into. Well, that would be 18. So to get 9 to 18, I'm going to have to multiply this top equation by 2. And to get 2 to 18, I'm going to have to multiply by 9. So when I do that with every term, so 2 times 10 is 20x, 2 times 9 is 18y, and that's going to be equal to -510. Multiplying 9 times each term, 27x minus 18y equals -54. Now I can add, and when I add, I'm going to eliminate my y's, and I'm left over with 47x equals -564. Dividing both sides by 47, I end up with x is equal to 12. Once I find x, I put it back into one of my original equations to look for y. So in this case, I'm going to put it back into the second equation. That looks a little bit nicer. So 3 times 12 minus 2y equals -6. So I'm putting it back into the original equation. 3 times 12 is 36. Minus 2y is -6. Subtract 36 from both sides. -2y equals -42. And divide by -2, y equals 21. So the point of intersection is going to be the point 12, 21. And again, I should go ahead and check. I should put 12 into both of my equations for x and 21 into both of my equations for y and see if they check out. So 10 times 12 plus 9 times 21. Is that equal to, well, I already see a mistake. This isn't going to, that's not going to equal -255, is it? Both of these are positive. So I'm looking back to see if I made a mistake somewhere, and look at right here. This should have been a -12. So coming back through here, this should be a -12. This should be a -36. This should be a positive. So this Doesn't make sense anymore. And we're left over with negative 2y equal to positive 30. Dividing by negative 2, y has to equal negative 15. So my answer, my point of intersection, should be negative 12, negative 15. So let's go back through. We know this one's not right. Try it again. So I'm going to do 10 times negative 12 plus 9 times negative 15. And is that equal to negative 255? And after using my calculator, yes, that checks. Then try the second equation, because it could work in the first, but not the second. So is 3 times negative 12 minus 2 times negative 15 going to be equal to negative 6? 3 times negative 12 is negative 36. Negative times a negative gives me a positive 30. Is negative 36 plus 30 equal to 6? Yes, it is. And therefore, my answer to my second equation now is negative 12, negative 15.